Hello, class, my astute researchers, right? Here we are. Let me fix the slideshow here. Here we are for video 18, and we're going to talk today about statistics. And so I'm going to break this down for you so that it's not scary. I want it to be easy to understand. And so I'm going to try and break it down for you so that it's easy. So the first thing we're going to talk about just with this video is that you can think of statistics with basically two different groups. And one of the groups of statistics you've kind of learned about already. You've learned about central tendency. You've learned about what's the average. Most of you have learned that since probably elementary school. And so descriptive statistics are the ones that tell you about the sample. They don't compare anything. They just tell you about the sample. And so if you want to know what's the average age, what's the range of ages, what's the youngest and the oldest, or where are most of the people in terms of their age? Is there a lot of people who are old and young, or is it mostly they're all in their 30s? Descriptive statistics tell you about that. They tell you how many people are of which gender in your study. They'll tell you what the average or median income is, or they might tell you the average level of education. So when you're looking at descriptive statistics, the thing to remember is they're going to describe the sample to you. The other group of statistics is called inferential statistics. So with inferential statistics, what you're doing is you're inferring. So if you know anything about logic, you're making an inference. You're trying to infer something that might be true about the sample. Of course, your confidence in whether or not it's true depends on other things like, this is where the P level enters in, the probability that whatever you see is due to chance or is due to reality. We're going to talk about that in class later on. So inferential statistics is the other group of statistics. This one is where you're going to compare your sample to something else, or you compare your group to something else, or you compare the groups that are in your study to each other. Whatever the case is, you're making a comparison, and then you're using that comparison to try and infer some sort of truth. So you've got descriptive statistics that describe the sample, and then inferential statistics that will compare the sample to another group or to the population as a whole, etc. So here are some examples. If the average score in the sample is like say 163, you know that that's what the average score is. You're saying this is a fact. The average score is a fact. The mean is 163 or the mean is 149. That's what it is. Okay, well, that's great. But now what does it mean? And that's where inferential statistics come in. How do you know if these two average scores or means? Oh gosh, I'm getting a little, confusing here saying, are the means, what do the means mean? Yeah, that comes up. So if these two means, are they really different from each other, or are they really kind of more the same? Well, that really depends on what the whole sample looks like. And so you can't use descriptive statistics to tell you if those two means are the same or different, or similar or different. You need to use inferential statistics. So you're interpreting or telling what the meaning is using inferential statistics as opposed to just stating facts. That's another way of looking at the difference between a descriptive statistic and an inferential statistic. So we're going to look at an example. Here we are again with our eveningness study, and we have a table that tells you the demographic and clinical characteristics of the patients who are treated with the trans-C intervention, and then the patients who are treated with just the psychoeducation. And so what you're doing is you're just looking at the average characteristics that are in each group. And so in the trans-C, there were 49 of them, and 55% of those 49 were females. In the psychoeducation group, we had 53 who were there, who were females, and that meant that there were 61% of the entire sample were females. They're making this smaller. They're making the table smaller by making you just kind of figure out if there's 89 people in the trans C group and 49 of them are female, obviously the rest of them are male. So they're figuring you can just make those calculations on your own instead of putting them all in the graph. Not everyone does it this way. Sometimes they do the extra work for you. In fact, I would say most of the time they do the extra work for you. It's just when they want their graphs to be smaller, this is another way of doing it. So here are some examples of descriptive statistics. Here we have an example of what is going to be a comparison. And so this is an inferential statistic. And so I've circled in red the trans C group. So this table will show you which group is which. So on the left side, you have the trans C group. And on the right side, you have the PE group. Now, I drew a line down the middle to help you, but what the table is showing you are 3 things for the trans C group and 3 things for the PE or the psychoeducation group. So the 3 things you find out about each group are what's their baseline score, what's the score after the treatment, and how much change was there from the baseline to the post-treatment. What's the pre to post change? And so you get those numbers for both groups. And so there could have been a line down the middle to help you see it, see the division between the 2 groups more easily. Here they left out the line. I drew it in for you so it would be easier. And so what you're looking at are baseline in both groups is about 459, 454. That's not a huge difference here. And then you look at the post-treatment. Well, that is different from each other. One's 482 and one's 464. But we don't know for sure that it's different. It just looks different. And so we have to do an inferential statistic to figure out if it really is different. And over in the last column where it says treatment by time interaction, that's where they've done this inferential statistic. And I'm not going to confuse you by what it is exactly that they're doing, but that side of the table tells us the p-value of whether or not that seems to be statistically significant difference. So what we're seeing here are 2 groups. They're being compared using inferential statistics so we can see if there is a difference between those 2 groups. Great. Okay. When we talk about statistically significant change, I want to make sure that we start with this understanding that significant in this case only means one thing. It means statistically significant. In other words, statistically, there is a difference. It doesn't mean how big the difference is. It just means there is a difference. So a lot of times people will say, well, this was a very significant result. And even researchers get stuck doing this, and it's not correct. What they're doing is they're saying that their data shows a huge difference. But what they're really trying to do is explain how big a deal they see their data as. And the statistics don't really back that up. All the statistics are saying is, yep, those 2 numbers are different. They are different enough that they would not have occurred this way by chance alone, except for maybe 0.01 of a percent of a time or 5% of the time, whatever your p-value is set at. That's how you decide the percentage of times that you would find these results by chance alone. Now, if you don't understand that, that's okay. We're going to go over it again. What I do want you to understand is that the word significant just means one thing. It just means it's statistically significant. In other words, it's the probability of it occurring by chance is low enough that the sorry, that these 2 numbers really are different. Okay, so that's it. Descriptive. sorry, descriptive statistics describe, and inferential statistics interpret. That's the main thing to know here.